Hello everyone, welcome back to this lecture. So as in the previous lecture, we were discussing about the math statements, right? Which is 4.6. So about math statements, we were discussing and only a small part was remaining. That is the key features of math statement, right? So that we are going to cover in this particular lecture. So the first point is, like unpacking assignments, tuple and list patterns have exactly the same meaning and actually match arbitrary sequences. An important exception is that they don't match iterators or strings. Okay, so that means basically here whatever math statements we write, okay, so we have already seen that how when we take some point then unpacking and all are done, right? That I have discussed in the previous lecture. So here how unpacking assignments work in the very similar way, tuples and list patterns also we can give here. Okay, so we can take a list here and that will get unpacked, okay, and then based on that the pattern will be matched. So tuple and list both can be used. Just one exception is there, that is any iterator or strings cannot be used here. So that is the first feature. The next one is sequence patterns support extended packing. Okay, in extended packing, unpacking, what is there? That first of all, few variables you can write which are fixed, and here you can also write one particular parameter like this, which is your asterisk, and then some variable name which is here written as rest. Okay, so here it means what, that inside this multiple values can be present. Okay, not only one two, means here whatever elements are there they can vary in number. So for that we write it this way. Okay, so as you can see this is written in a list form because square brackets are there, and here this is written using parenthesis. Okay, so this is a tuple, so we can also write the list and tuple in this format, and here also unpacking will be done. So this is known as extended unpacking. Okay, so it works similar to unpacking statements. Okay, so match, in case of match statement, this extended unpacking is supported, so you can write the patterns like this also. So the name after asterisk, okay, may also be underscore. So here, like whatever name is used here, like here rest is written, so you can write any other valid identifier name, but also you can write underscore because it is also a valid identifier name, right? So it can be written this way. Okay, or you can take a list also which will have square brackets. So it matches a sequence of at least two items without binding the remaining items. Okay, so at least two, like x and y is there, so at least two will be definitely matched, and after that it depends on rest of the values here. Okay, so that is also one feature, that we can also write extended unpacking and all. After that, mapping patterns like this. Okay, this is a dictionary, right? Because some key value pairs are there. Okay, bandwidth is the key and the value is b. Similarly, latency here, this string is a key and L is the value. Okay, so like this key value pairs are there in the dictionary. So it captures the bandwidth and latency values from a dictionary. So if you are writing a mapping pattern where dictionary is there, so then also it will work. Okay, and in that case it will consider all the keys. So unlike sequence patterns, extra keys are ignored. Okay, so if any extra keys are there, let us say you are matching only two, let us say only two keys you are matching, but the dictionary contains more keys also, in that case whatever extra keys are there, those will be ignored. Okay, and unpacking like double asterisk, and then if you're writing rest, then this is also supported, it is completely valid. Okay, but the thing is that if you write it this way, that is underscore you're writing, okay, along with double sticks, double asterisks, then what happens, it actually creates redundancy because the meaning is not changed, it is very similar to this only, right? Here by single asterisk and underscore both have the same meaning, so since it is redundant, that is why it is not allowed. Okay, but with any other identifier name you can write double asterisk. After that, the next point is sub patterns may be captured using the as keyword. Okay, so you can also write the case like this, like here it is written point x1 y1 and then point x2 y2, that one you are giving a different name to it, that is as p2. So later on you can match it with p2. Okay, so we'll capture the second element of the input as p2 as long as the input is a sequence of 2 points. Okay, so it will be captured as P2. All right, the next point is most literals are compared by equality, right? Literals means the literal value, the exact or constant values. Okay, like numbers 2, 3, 4, these are literal values. Okay, so most of the literal values are compared by equality, because we know that whenever we are writing some math statement like this, like here match color is written, so after that here whatever cases are there, then it will be matched, right? That they are equal or not in value. So how they are matched? They are mostly matched using equality. That means equal operator, right? Equality operator. So by that equality operator, if the values are matching, then the math statement matches there and that particular case gets executed, right? That is what generally happens. But in case of singletons, which are true, false and none, for these three values, identity, as per identity the values are compared. Okay, like A is B, B is C, right? So is keyword is used there, so because as per identity we compare the values. Okay, so that is the internal part. You will be writing the math statement as it is. Okay, like if you have to match it with true, you will write here true, and okay, but internally how they are compared, that is what is mentioned here. So if literals are there, they are compared by equality operator, and otherwise for the singletons by the identity they are compared. Okay, so that is the internal detailing. After that, here it is there that patterns may use named constants. Okay, some named constants like this can also be used. Okay, but in that case it must be dotted names to prevent them from being interpreted as capture variable. Okay, like for this example it is given, like from enum, import enum. If you're not very much aware of enumeration and all, it is okay. Just you consider here that these red, green, blue, which are written in capital letters, they are some constants. Okay, and in that their constant values are assigned. Okay, which are the strings red, green, blue in small letter. Okay, so after that here we are taking the input, right? Now here we are matching this color, right? This color has been given by the user, right? So with that we are matching these constant. Now whenever you are trying to match the constant, you will not write directly red, that is capital red, you will not write. Okay, so you cannot write only this red, you have to write it color.red. Okay, this color is coming from this class name, right? And then dot, then red you can write, because these are named constants. Okay, otherwise if you write it directly, then it will be considered as a simple variable, but it is not like that. It is, you know, some named constants and all, so that is why the meaning little bit varies internally, so you have to use it like this. Okay, so if you're trying to use the named constants, you have to write it in the dotted form. So here the example is given. You can take this example and try in your terminal, right? And you can see that how it is working. So here all the key features of math statement ends. And for a more detailed explanation and additional examples, you can go to this link and see. So this in itself is a complete tutorial again. Okay, so I'm just showing you. It is actually Python enhancement proposals. Okay, PEP means Python enhancement proposals. Okay, so this in itself is a complete tutorial about structural pattern matching. So you can go through this if you want to know more about it. But otherwise, in this particular tutorial, I will be moving to the next topic in the next video, that is 4.7, which is defining functions. So I'm ending this lecture here. Thank you.